Hi, so in this video I will discuss the alcohol Marangoni boat propulsion. So we'll start with a little demo. So here I have a small boat and there's basically a small indent where I'm going to pour in some alcohol, and when I pour it in it will mostly flow from this side, and so some of the alcohol will flow out, and the question is whether by having the alcohol flowing out, will actually the boat be attracted by that, will be pushed away by it, or nothing will happen. So let's find out. So I'm going to put it here in a stable position. I'm a little electrical, so let me use actually um, a spoon, and then I'm going to fill it with some absinthe, which is a sort of a strong alcohol. Try to not spill it over. I'm just going to fill it with alcohol as much as I can, and it's sticking to the edge here. So let me fill this until some of the alcohol runs out, and you see, as soon as the alcohol came out, the boat is basically propelling by pushing it away from where the alcohol is dropping. Okay, so it wants to, if you turn it around, it comes back. Let me turn it back around again. It's basically propelling by the alcohol, which is coming out from the back of the boat. Let's turn again, and you see it's quite efficient way to propel the boat. Okay, so we still has some fuel in there left, and as soon as I turn it, it comes back and it propels. So this is a small alcohol boat propelled by leaking out alcohol. So if you have a boat and you want to propel yourself, you just need a bottle of strong alcohol, and then make a hole, and it will actually it will be replacing your engine. But don't try that on in the ocean. Okay, so let's try to understand how this propulsion by alcohol loss actually works. And so here we have the graph of this. This is the boat, where we have the alcohol, which basically is flowing out on one side. And so what we have in this area is that we're going to have the water surface, which is changed by the presence of this alcohol. And so the difference between alcohol and water is that water has a much higher surface tension than alcohol. And that's the reason that in water you would have water droplets forming, but alcohol will not have easily water droplets or droplets forming. And so this surface tension, which basically makes the water droplet, basically it's a force which wants to push together the water. And so what that is that basically the water wants to actually get together, and so it basically just pushes all the water, tries to attract the water together. And so on this side we have this strong force of the water, while on this other side this force here is going to be much smaller because the surface tension is weaker. And so finally the total force is just the difference between the force from the water on one side, on the front, minus the force on the back. And so this is going to be positive because the surface tension of the fuel of the alcohol is smaller, so that's this sigma fuel is basically going to be smaller than the sigma of the water. Okay, and so because of that difference in surface tension, we're going to get a force driving the boat towards the right in this picture. And so that's basically the mechanism behind this nice boat. This mechanism of the alcohol propulsion is actually quite general, and you could also replace the alcohol by soap, which soap has a much lower surface tension than water, and so you will essentially have the same effect when you replace the alcohol by soap. So the surface tension really plays sort of interesting role, especially in alcohol, because it's lower. And so let's look at a slightly different effect of the surface tension of alcohol and water. So here we have an empty glass, and I'm going to fill it with some wine. And we're going to look at sort of what happens at the interface of the wine and the air. What is really fascinating here is this sort of continuous formation of droplets. And so on the one hand, you have the alcohol which goes up, and then it evaporates, and so the alcohol content got less, and then it's less alcohol, so it's more water, and that will actually fall down again through gravity. And that happens in a continuous way, and this is sort of a high-speed imaging of this, but it's sort of really a continuous process and driven by gravity on one side and the lack of surface tension of alcohol, which makes the fluid go up, the alcohol go up, and then after evaporation forms this droplets which fall down again, and this repeats on and on. So here we really saw two sort of interesting mechanisms related to the surface tension of water and alcohol and the difference of that. And so this interplay, this difference between the surface tension of alcohol, which is much lower than water, can actually propel a boat like we've seen at the beginning, or can also have these influence the dynamics, having this sort of dance of droplets which fall down, but at the same time the alcohol going up and the droplets falling down. So it's kind of a really nice illustration of this effect of surface tension in liquids. So with this, I hope you enjoyed the video, and I thank you for watching.